Just another day in chem lab. Oh, hey, Mr. Park.
Hey, Mr. Troll, look at this.
What is that?
It's a new element.
Another new element?
That's right.
I don't know if you should be getting so close to that, Mr. Park. That could burn your skin, or
But it's not like it's radioactive.
how do you know?
Good point. Let's pull out the Geiger counter. Let's
I just
check
happen
it.
to have my Geiger counter on me. I carry it everywhere I go. What's a Geiger counter?
It detects ionizing radiation, which is the bad kind.
Uh-oh. Uh-oh.
I'm hearing something.
Mr. Park. It sounds like this sample might be mildly radioactive. You should be careful.
Maybe I should get gloves. All right. You know what? I'm going to call this Cubium.
Why?
I don't know. Just a hunch.
Oh.
So now that we've determined that Cubium is radioactive, we're going to run a simulation that shows the rate of decay. And so when I spill these Cubium atoms out onto the counter, every time one of the atoms lands with the red painted side facing up, that's going to simulate a decayed nuclei. And
Do
then
they each just have one side painted?
they each just have one side.
Okay.
Right. So I counted these atoms before we started. There's 100 of them at the beginning. So that's why in our data table, 100 is the number of undecayed at the very beginning. So,
What do you mean by undecayed? What does decayed mean?
well, a decay is when an atom, a radioactive atom, splits and emits a particle, a nuclear particle. So when that happens, we say it undergoes a decay.
Okay.
So undecayed are ones that have not done that yet.
And after it decays, it becomes something new?
It becomes a new element, yes.
So it's not going to be cubium anymore after it decays?
Right.
Oh, cool. Okay, so what's the simulation? What are you going to do?
So by spilling these out onto the counter
Cubium!
and patting them down flat,
Just a random throw?
that's right.
Oh.
All of the atoms that turned red, we're going to remove them from the population.
Get out of here.
Do you see any others?
No, one more.
Oh, yeah. All right.
Okay. How many
So,
is that?
We removed, let's see, 3, 6, 9, 12, 13.
13.
13 atoms were removed.
So that was on your first roll. So roll number 1. 13 decayed.
Now, since we started with 100, 87 of them are undecayed.
So you just subtracted that value from the total.
That's right.
Okay. Well, let's put all 100 back in the beaker now, and let's do another roll. That was
Well,
fun.
we can't put all 100 back in because 13 of them had decayed, so they're not cubium anymore.
Oh, so there's only 87 cubium left.
Right. So
Got
we're
it.
starting with just 87 on the second trial.
I'm a little slow on the uptake. I get it now. Okay. Ready?
Trial number 2.
Cubium! It's like Yahtzee, only better.
2, 4,
I think any of our
6,
students have played
8.
Yahtzee.
10, 12, no. 15, 16, 17. All right, so 17 decayed that time.
Okay.
It's a little higher, but in the beginning stages, it's okay. All right, so we are down to 70.
Okay. Cubium! All right, this was the 70 cubes. One more. That one snuck in there. He's not red.
Okay, so it's 9.
9. Cubium!
This was 10.
Hey. 51 cubes. We hit the table.
4.
4. All right. Okay, 47. Cubium!
7.
7. Oh, I thought we were almost done. Then you moved the page over. And woo! Man. Talk about a good time. 4?
4.
Of the 36, 6 of them. And Cubium. Just 2.
Just 2.
Luck of the draw. Okay. 28 cubes hit the table.
3.
And 25 survive. And ooh, no. Got a rogue Cubium over there.
4.
4? Five. Are you doing all this math in your head?
I am.
That's impressive.
That's what you go to college for.
Beautiful weather we're having.
3.
Now, if you roll 11, I'll be very impressed.
So will I.
Oh!
Just one.
Just one.
All right, that's good enough.
Nice work, Mr. Park.